Good morning, boys and girls. This is Miss Estes, and today we are going to practice multiplying multi-digit numbers using the standard algorithm. Our I can statement is I can fluently multiply multi-digit whole numbers using the standard algorithm. So when we multiply using the standard algorithm, we are multiplying each digit in the first factor by the second factor. So here we have a 4-digit number and we're multiplying by a 1-digit number. So we're taking this second factor, 3, and we're going to multiply it by every single digit in that top factor. So 9 times 3 is 27. So we put the 7 in the ones place, and we carry the 2 over to the tens. Then we have to multiply by the tens. 3 times 6 equals 18. Then we have to add the 2 that we carried. So that would give us 20. We put our 0, and then we carry the 2. Now we're going to multiply by the hundreds place. 7 times 3 equals 21. Add the 2 that we carried. That gives us 23. So we put the 3, then carry the 2. Then we have to multiply by our thousands. 5 times 3 is 15, plus the 2 that we carried gives us 17. So our product would be 17,307. So in our first example here, let's work this together. We are multiplying 3,562 times 7. So we're taking this factor 7 and we're multiplying it by every digit in the top factor. 7 times 2 is 14, so we put our 4 and we carry the 1. Then we need to multiply by our tens place. 7 times 6, that's 42, plus 1 is 43. Then we're going to take the 7 and multiply by the hundreds. 7 times 5 is 35, plus 4 is 39. Then we're going to multiply by the thousands place. 7 times 3 is 21, plus 3 is 24. So we have a product of 24,934. If we look at our second example, we have 7,283 times 6. So we have to take this factor 6 and multiply it by every digit in the top factor. 6 times 3 equals 18. So we put our 8 and carry our 1. Then we multiply by our tens. 6 times 8 is 48, plus 1 is 49. Then we multiply by our hundreds. 6 times 2 is 12, plus 4 was 16. And then 6 times 7, 42, plus 1 is 43. So our product is 43,698. So now we're going to take a look at multiplying by a 2-digit factor using the standard algorithm. And in our example, we have a 3-digit factor. We're still doing the same steps. We're just going to take it one step further. So in our step 1, we have to multiply each digit in the first factor by the second digit, by the first digit in the second factor. So if we look here, we're going to multiply this 5 that's in the ones place by 3, then by 8, then 5 times 7 to get our first partial product right here, 3,915. Then we have to repeat the steps for each digit in the second factor. Tens place, then hundreds place if needed. So next we would multiply by the 3 in the tens place. Since we are multiplying by the tens place, we always have to make sure that we add 1 0 before we multiply by the tens place. So we multiply 3 times 3, 9, 3 times 8, and then 3 times 7 to get a total 23,490 as our second partial product. Since we do have a digit in the hundreds place, we're now going to multiply by the hundreds. So this time we have to add 2 zeros because we are about to multiply by the hundreds place. Once we put our 2 zeros, then we can start multiplying. 2 times 3 is 6. 2 times 8 equals 16, so 6 and carry the 1. 2 times 7 is 14, plus 1 is 15, and there we go. So since we were multiplying by a 3-digit number, we have 3 rows of partial products. And our very last step would be to add all of them together to get our final product of 184,005. So now let's use what I like to call the TIC-TAC-ZERO strategy to help us go step by step through the standard algorithm. 3 times 4 is 12. So we put our 2 and we carry our 1. Now we're going to multiply by the tens. 3 times 6 equals 18, plus 1 is 19, and then carry our 1. Now we have to multiply by the hundreds. 3 times 7 is 21, plus the 1 that we carried is 22. So our first partial product is 2,292. Now we're going to use what I call the TIC-TAC-ZERO strategy. And this just helps us remember to cross out what we're finished with, so that way we are less likely to make a careless mistake and try to multiply by the wrong number or add something again after we've already added it. So when we say tick, we're going to cross out that ones place. We're finished with the ones place. We don't need to multiply by that 3 anymore. So crossing it out is going to help us remember that we don't need to multiply it by anything else. TAC means we're going to cross out what we regrouped, because we've already used those numbers. We're not going to use them again. And then 0 is going to help us remember to put that 0 in the ones place, because now we are ready to multiply by the tens. So once we put our 0, we can now multiply by our tens place. 4 times 4 is 16. So we put our 6 and we carry our 1. Now we multiply by the tens. 4 times 6 is 24, plus 1, 25, and then carry our 2. Last, we need to multiply by the hundreds. 4 times 7 is 28, plus 2 gives us 30. So now we have a row of partial products for multiplying by our ones, a row of partial products for when we multiply by our tens. Now we need to add the 2 together. 2 plus 0 equals 2. 9 plus 6 is 15. 5 plus 2 is 7, plus 1 is 8. 2 plus 0, and then bring down our 3. So our final product is 32,852. So now let's use our standard algorithm to multiply a 4-digit number times a 2-digit number. So we're going to start with the 7 in our ones place, and we're going to multiply it by every place value starting with our ones. 7 times 4 is 28. 7 times 7, 49, plus 2, so it's 51. 7 times 3 is 21, plus 5, 26. And 7 times 6 is 42, plus 2, so that gives us 44. So now we're going to use that TIC-TAC-ZERO strategy. So what does that mean? What does TIC mean? Yep, we got to cross out our ones place, because we're not going to multiply that 7 by anything else. When we TAC, what does that mean? Correct, we're going to TAC or cross out our what we carried, because we're not going to need that anymore. And then 0, we're going to include our 0 in the ones place, so now we can multiply by our tens. 2 times 4 is 8. 2 times 7 is 14, so we carry our 1. 2 times 3 is 6, plus 1 is 7, and 2 times 6 is 12. So we now have a row of partial products for when we multiplied by our ones, a row of partial products when we multiplied by our tens, and now we are ready to add. 8 plus 0 is 8. 1 plus 8 is 9. 6 plus 4 is 10. 7 plus 4 is 11, plus 1 is 12. 4 plus 1 is 5, plus 2, 7, and then 1, or comma, 172,098. Thank you guys for joining me today for learning how to use our standard algorithm. Also, remember that TIC-TAC-ZERO strategy to help you remember your 0 before multiplying by your tens place. Thank you for joining me today, and have a nice day.